All right, we are back. Part 2 of Laws of Probability. And we were just about to start Part D here. I'll work that one up here. Okay, so what is this really asking? Find the probability that the student dislikes pineapple. Dislikes pineapple. So that's the probability. How do we represent disliking pineapple? We represent that with a prime. Given that he or she likes bananas. Okay. Now, the formula for this, if I had to use this, let me get rid of this. Now, let me back up. We are definitely going to use the Venn diagram. If you can use the Venn diagram, that is the way to go. But I just want to show you how to write the formula when you encounter problems that you're not going to be able to use a Venn diagram. So your first event is P prime, and your second event is B here in this order. So this formula, probability of P prime B, given B, I'm just anywhere I see an A, I'm replacing it with P prime. So that's going to be P prime intersect B over probability of B. We got lucky. The B's match up here. Okay, so let's think about this. We know that they like bananas. We're only talking about the group of students who like bananas. So that is equal to something over 34, since 34 of the students like bananas. And what's the probability that they don't like pineapple? Well, 18 of those people like pineapple, so the ones that don't like pineapple are the ones who like bananas only. That's 16 out of 34, which simplifies to 8 out of 17. Okay, one more example. We have the top shelf in a cupboard contains 3 cans of pumpkin soup and 2 cans of chicken soup. The bottom shelf contains 4 cans of pumpkin soup and 1 can of chicken soup. Lucas is twice as likely to take a can from the bottom shelf as he is from the top shelf. If he takes 1 can of soup without looking at the label, determine the probability that it blah, 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 blah. This is definitely not a Venn diagram, but it's screaming for a tree diagram. Okay. So the first thing is he's either going to select a can from the top shelf or he's going to select it from the bottom shelf. So this is where you got to think about it. If he's twice as likely to take a can from the bottom shelf as he is from the top shelf, that's 2 to 1. Okay, 2 times as likely as from one from the other for a total of 3. If you want to think about it that way for our probability. And what is it again? 2 times as likely to take a can from the bottom shelf. So that's 2 to 3, and this is 1 to 3. This is twice as likely as this. Okay, so then what happens? Well, then he can either take, what do we have? We have pumpkin soup and we have chicken soup. And on the top shelf, his chances of taking pumpkin are 3 out of 5, and chicken is 2 out of 5. And then on the bottom shelf, we have pumpkin and chicken again. What's the dealio here? Bottom shelf, 4 out of 5 for pumpkin, and 1 out of 5 for chicken. Okay. So if he randomly takes a can without looking at the label, find the probability that it's chicken. Okay, so we have this and this. So the probability of chicken is going to equal, following the path, 1/3 times 2/5 plus 2/3 times 1/5. And I'm going to assume you all can handle the fractional part of this. That turns out to be 4 out of 15. Okay, that's the easy part. B. Find the probability that it was taken from the top shelf given that it is chicken. So we're finding probability of T given C. And using our formula, that's going to be the probability of T intersect C over the probability of C. Okay? Well, let's think about this intuitively. The probability that it came from the top shelf, given that it is indeed chicken. Okay? Well, the only possible way for this to occur is if it's on the top shelf. Okay, so this is another reason we can't cancel it out. We're gonna work backwards. It's chicken, given that it's the top shelf. So this intersection here is probability is equal to 2 over 5 times 1 over 3, because that's the only way that we can get chicken from the top shelf, is this path right here, over the probability of chicken, which we found before, which is 4 out of 15. So this becomes 2 out of 15 over 4 out of 15. The 15s will cancel out. We get 2 over 4, which equals 1 over 2. And that's it. See you next time.